Hello everybody and welcome to this week's lesson. This week we are focusing on writing, solving, and graphing one variable linear inequalities. This lesson builds directly on our lesson from last week. So last week we were working on writing and solving one variable linear equations. Everything we do this week is going to be very, very similar to what we did last week. So if you haven't watched last week's lesson, make sure you go and watch that recording. If you need a little refresher on last week's lesson, you can also go back and rewatch that recording before you watch this lesson. For this lesson, you're going to want pencil and paper to take notes with. You might want your notes from last week's lesson. And you can use a calculator if you'd like. And other than that, you can have your welcome pack out next to you as well. All right, so our learning goals for this week, we're going to solve linear inequalities in one variable with rational number coefficients. We're going to identify or graph the solution to a one variable linear equation on a linear inequality on a number line. We're going to solve real world problems involving inequalities, and we're going to write linear inequalities in one variable to represent context. So we've got those 4 goals, very, very similar to our goals from last week. All right, let's start with our warm-up problem here. This is again from last week's lesson, so it should look familiar if you have watched that. Hannah is renting a moving truck. There's a rental fee of $20 plus 25 cents per mile. If she pays a total of $30, choose the equation below that represents the number of miles she drove, X. So we're going to take a look at our 4 answer choices here. I'd encourage you to pause the video and think about the problem, choose what you think is the answer, and then come back when you're ready to go through it with me. All right, so let's think about the situation here. When I look at my 4 answer choices, I see that for all 4 of them, we've got equations where the total payment is on one side. So we have her total bill or her total payment of $30 on one side of the equal sign. And then I know that up here in the description, they gave me information about what goes into that total. So what are the different components that we have to combine together to get her total bill? So on the other side of this equal sign here on the right side, I want to be thinking about what goes into that total amount. Well, I know she has the rental fee, so the rental fee of $20. And then it says plus, so we don't even really have to think very hard about that one. We know it's just going to be plus 25 cents per mile. And we know we're choosing the equation that represents the number of miles she drove, X. So in all of these equations, X is supposed to be the number of miles she drove. Let's think about how we would calculate that mileage fee. So 25 cents per mile, and she drove some number of miles. If we knew how many miles she drove, how would we calculate the fee she has to pay for those miles? Well, we would do 25 cents times the number of miles she drove, right? If she drove 1 mile, she only has to pay 25 cents. If she drove 2 miles, she needs to pay 50 cents. If she drove 3 miles, she needs to pay 75 cents, and so on. So what we're doing there is we are taking that rate of 25 cents per mile and multiplying it by the number of miles that she drove. So we've got her total payment of $30, which is equal to that rental fee that she has to pay, and that mileage fee that she has to pay based on the number of miles she drove. So I've got an equation here. Now looking at my answer choices, this doesn't exactly match any of the answer choices. However, it is actually the same thing as answer choice B. So the version I wrote down here, the 20 and the 0.25x are flipped around, but that doesn't actually matter in terms of the meaning of the equation because we know that for addition, order doesn't matter. So 20 plus 0.25x has the same meaning as 0.25x plus 20. So choice B would be our correct answer here. Choice B is really just mathematical shorthand for this verbal description we have at the top of the page here. It's saying that the total bill of $30 is equal to 25 cents per mile times the number of miles she drove plus the $20 rental fee. All right, so as promised, this week we're, instead of focusing on equations, we're going to be focusing on inequalities. Now in math, an inequality is a mathematical statement comparing two expressions. So with an equation is a mathematical statement that says two expressions are equal. With inequalities, it's a little more general. We're just comparing two expressions. And we have 4 different symbols that we're typically using for those comparisons. And those 4 symbols are on the page here. So we have is less than, we have is greater than, we have is less than or equal to, and we have is greater than or equal to. So those are our 4 symbols that we're going to be focusing on for inequalities. And I have some examples down at the bottom of the page here. Some of these examples are just using regular old numbers. Some of them include some variables in there for some algebraic expressions. So this first inequality, it says 1 is less than 2, which I think we can all agree on, right? The second example says 2 is greater than 1, which is also true, I think. If my coffee has kicked in, then I'm pretty sure it's true. Notice that these 2 statements basically say the same thing. They're talking about the same relationship. All we've done is kind of flipped everything around, but it's the same relationship between 1 and 2 that we're talking about. So that's something that is generally true for inequalities. You can take the inequality and flip it all around, including the symbol, and it preserves the meaning of the original statement. So with equations, last week we talked about how you can flip around either side of the equation and it doesn't affect the meaning because you're just saying they're both the same. Now with inequalities, we have something really similar, except we also have to think about flipping that inequality sign. All right, and then I have another statement here that 1 plus some number x is less than 5. We have 6 minus x is greater than 1. X is less than or equal to 10. And 20 is greater than or equal to 2 times x. So no particular reason why I chose those inequalities, just made some up as examples. All right, so these comparison symbols, like I said, they're part of our algebraic language. They're part of our mathematical shorthand that we're learning to write in. And they are used to represent ideas that we talk about in English or whatever language we're speaking in. They're used to represent these comparison ideas. And now when we talk about actual language that we use, like English or other languages, there's always more than one way to say something, right? So what I have on the screen for you here is I've got some key words and key phrases that are associated with each of these comparison symbols. So we already talked about the top ones in each of these lists, but I've got a couple more examples in each category. So for the less than symbol, you could also say smaller than or fewer than. For less than or equal to, you could say at most, no more than, does not exceed. For the greater than symbol, you could also say larger than, more than, or exceeds. And is greater than or equal to, you could also say at least or no less than. So those are some key phrases that'll show up a lot in problems that are dealing with inequalities. You should be on the lookout for these phrases. You might even add these phrases to your keywords handout in your welcome packet so that you can refer back to them if you need to. But you definitely want to write these down somewhere and practice with them, practice learning them so that you so that you can quickly associate the symbol with the phrase when you're working on problems. Okay, so let's look at an example of how we would take one of these phrases and translate it into an inequality. The example says a child must be at least 4 feet tall to go on the ride. Represent this as an inequality. So what I've done here is I've got my variable h, which is supposed to be like the height of the child. I just chose h to represent height, but you could have done any letter really. So h is greater than or equal to 4. Now, why did I choose greater than or equal to? Well, I see the child or a child must be at least 4 feet tall. The child must be at least 4 feet tall. So their height must be at least 4 feet. If I go to my chart up here, I see that at least is another way to say greater than or equal to, and so I choose this greater than or equal to symbol. Another way to think about it is the child can be 4 feet, right? 4 feet is acceptable, so that's equal to 4 feet, but they can also be taller than 4 feet. Their height can be greater than 4 feet, so that's why we choose the height is greater than or equal to 4. All right, let's get some more practice here with writing one variable linear inequalities. So again, this would be an opportunity for you to pause the video, read through these problems and give them a try. And when you're ready, start the video again and we're gonna go through them together. All right, so number 1, Donnie must read at least 300 pages for his philosophy class this week. Choose the inequality below that represents what his daily page goal should be. Right, so he has this big thing he has to take care of, right? He needs to read at least 300 pages. So he needs to make a plan for how many pages he needs to do each day. So if I look at all 4 of the answer choices, I see for all 4 of them, it looks like on one side, we've got something to do with his daily reading goal. And then on the other side, we have that total page amount of 300. So what I'm going to do is I'm going to focus here on my keyword. So he must read at least 300 pages. He must read at least 300 pages. Well, we just talked about that phrase at least in the last example, right? We know that at least 300 means the same thing as greater than or equal to 300. So even without really worrying about what this 7x stuff means, we could really already decide that choice A has to be our answer. But let's think about what that 7x means. So it says choose the inequality below that represents what his daily page goal should be. So we don't have a number for that daily page goal, right? We haven't figured that out yet. So I'm going to assume that that's what the X is representing. X is whatever his daily page goal is. And since we're talking about a week, I think that's where the 7 comes from, right? So 7 days in a week times whatever his daily page goal is, that needs to get him up to at least 300 pages. So 7 days in a week times some number of pages per day is going to be greater than or equal to 300 pages. So choice A is our correct answer there. Notice that this problem did not ask you to figure out what his daily page goal should be. It says choose the inequality that represents what it should be. All right, number 2. To go in the bouncy castle, a child's weight must not exceed 90 pounds, not 20 pounds, 90 pounds. Choose the inequality below that best represents the situation. All right, well, I'm going to focus in on my keywords here. It says the weight must not exceed 90 pounds. We go back to our keywords chart here. Must not exceed, that's very similar to does not exceed, right? Must not exceed, does not exceed, means the same thing. So must not exceed, the weight can go up to 90, but it can't go over 90. So it needs to be less than or equal to 90. anything that's not over 90. And so we see again here our, oops, not A. Getting a little ahead of myself. So our answer in this situation is going to be choice C. All right, so let's take a little moment here to recap what we know about equations and what we know about inequalities and compare them for a moment. So equations use an equal sign. That's what equations are. They're a statement about equality. Inequalities use one of the other four comparison symbols, right? So they're a statement about how two expressions are related to each other. When we get to actually solving linear equalities, we're going to find that they are solved in the same way as linear equations. So linear equations and linear inequalities, they're solved in basically the same way, except there's one extra thing we have to keep in mind if we're solving an inequality. So if we're solving that has one of our four comparison symbols in it. And that rule that we need to remember is that when you're solving a linear inequality, if you multiply or divide both sides by a negative number, so if you multiply or divide by a negative number, you must flip the comparison symbol. So that's what you are doing. It's not about if you see a negative number in the inequality. It's about if you, in the process of solving the inequality, if you need to multiply or divide by a negative number, you flip the sign. So if you had less than, it would become greater than in your final solution. So let's see some examples of solving linear inequalities. All right, so everything we know about solving equations still holds, right? So we have the same goal. What is our goal from last week? What is our goal for solving linear equations? So our goal is to isolate the variable. Our goal is to get the variable on one side of the equal sign. So we have the same goal here. Our goal is to isolate the variable on one side of the inequality symbol. And the way that we do that, the way that we isolate the variable, is by canceling out the numbers using inverse operations, right? So those are kind of the two key things we thought about last week when we were solving equations, is that our goal is to isolate the variable, and we accomplish that goal by using inverse operations. So let's take a look at number one here. Number one, when I look at the side of the inequality that contains the variable, I see multiplication. Right? It says 3x, or 3 times x. How do I cancel out multiplication? Well, I do it with division. So I'm going to divide both sides by 3. This multiplication and division cancels. And so if I bring down my symbol, I've got an x remaining on the left-hand side, and then on the right-hand side, I have 21 divided by 3, which is 7. So this is the solution to this inequality. If 3 times some number is less than 21, that means that number must be less than 7. And we can double check our work here if we want to, or if we have time. We can choose a number based on our solution. So it says x is less than 7. We can choose a number less than 7. Let's keep it easy. Let's say we choose the number 2. So what I'm going to do is I'm going to take 2 and plug it back into the original inequality. So I'm replacing x with 2. Keeping everything else the same. And let's see if we come up with a true statement. Let's see if we come up with an inequality that still makes sense. So we have 3 times 2. 3 times 2 is 6. Bring everything else down. So we end up with this statement that 6 is less than 21. That is true. So that indicates that our solution, x is less than 7, is true, that it makes sense. It will give us a range of numbers that fit this inequality that we started with. All right, let's try the second example here. I see we've got x over 2 is greater than or equal to 10. So x over 2, I know that that's another way of saying division, right? X divided by 2. So since I've got division on the side of the variable, I'm going to go ahead and cancel out that division using the opposite, using the inverse. So the opposite of division is multiplication. I'm going to multiply both sides by 2. The 2's over here will cancel each other out. I'm going to bring down my symbol. Over here on the left side, all that's remaining is the x. And over here on the right side, we've got 20. So our solution to this inequality is x is greater than or equal to 20. Now again, we could double check our answer. Double check our answer by, let's choose a number that's greater than or equal to 20, maybe 30. 30 would be nice and easy to work with. So I'm going to replace x with 30 in my original inequality. 30 divided by 2 greater than or equal to 10. Now let's see if that checks out. So 30 divided by 2, that's 15. So we end up with 15 is greater than or equal to 10. And yes, that is true. 15 is greater than or equal to 10. It's greater than 10, right? So that works out. That indicates to us that our solution was correct. It's giving us a range of numbers for x that makes sense. Now the stuff we're doing in green, right, that is optional stuff. That is just checking our answers. The actual answers, the actual solutions are the x is less than 7 and the x is greater than or equal to 20. All right, now let's take a look at 3. 3 is an example of a two-step linear inequality. Right, last week we worked on two-step equations. This is a two-step linear inequality. It's 2 steps because when I look at the side with the variable, I see 2 different operations. I've got multiplication here. I've also got subtraction. This should also stand out to you because we did an example like this last week, which was a little bit trickier than some of the other stuff we worked on. The reason this particular example is going to be a little bit trickier is because we are subtracting the part of the expression that contains the variable. So instead of saying 2n minus 4, right, where we're subtracting the 4, we're actually doing the opposite. We're doing 4 minus 2n, or take away 2n. Another way I could write this without changing the meaning at all is I could think of this as negative 2n plus 4. So I've rearranged the order of the expression here. And what I've done, I've rearranged it, but I've preserved the sign that's in front of each term. So in front of this 4, there's nothing, which implies that it's positive or plus. In front of this 2 is a minus, which implies, right, minus or negative. So I can rewrite it in this way. And when I do that, it makes it a little bit clearer. Oops, greater than. When I do that, it makes it a little bit clearer why we're going to choose to subtract as our first step. So this minus 2 is being multiplied with the n. We know that we should always take care of addition and subtraction first before we take care of multiplication or division. So I am not going to start by canceling out this 2. I need to start by canceling out this 4. Now you might look at this problem and think, well, it's subtraction, so I need to do the opposite. I need to add. But what we have here is 4. If you take 4 and then you add 4 to it, it's not going to cancel out. You're going to get 8. We don't want that. We want it to go away. We want it to go to nothing. So we need to do the opposite. We need to take away 4. Right? 4 minus 4 will go to 0. And I think that's a little bit clearer if we look at the version over on the right-hand side here, where we can see that this same inequality can be written as addition. Right? So it really is plus 4. and we are subtracting 4 to get rid of it. Okay, so I'm going to subtract 4 from both sides. That's something you want to look out for in equations or inequalities where you are subtracting, or where it's subtracting the term that contains the variable, right, instead of just a regular old number. So these 4's will cancel. I'm going to bring down my symbol. Over here on the left-hand side, I've got minus 2n remaining. And over here, right, 8 minus 4 is 4. Okay, so on the left-hand side with the variable, I see what I've got left is multiplication. To cancel out multiplication, I divide. I'm going to divide by that -2. -2 divided by -2 is just 1. 1 times n is just n, so it canceled out. I'm going to do the same thing on the other side. Now, I have just divided both sides of my inequality by a negative number. That's this rule that we just talked about, right? So if we divide both sides by a negative number, we must flip the comparison symbol. So in my next line here, I'm going to flip around that symbol. What do we have remaining on the left-hand side? We've got n. And on the right-hand side, 4 divided by -2 is -2. Right, for multiplying and dividing, if you've got different signs, you get a negative answer. So positive and a negative gives you a negative answer. All right, and I highly encourage you to pause the video right now and double check this answer. I'm not going to do it on camera. I'm going to challenge you to try this yourself. Pause the video, choose a number that is greater than or equal to -2. So it could be something like -1 or 0 or 1 or 2 or 10 or 1,000. Get real crazy. Just choose a number that is greater than or equal to -2. Plug it back into the original inequality like we did with the first 2 examples here, and see if you get a true statement at the end. If we've done our work correctly, you should get a true statement. All right, number 4. This is another 2-step inequality. I see I've got multiplication and addition. So this +2. I'm going to start by canceling out that addition. Subtract from both sides. Those 2's will cancel. So what do I have remaining here? I've got a -4. M. And then -10 minus 2. -10 minus 2 is -12. Right? If you start your day off with a -$10 in your bank account, so you're in debt, and then you spend $2 more, you're going to be more in debt. Now you're going to be $12 in debt instead of $10 in debt. Okay. Now, again, focusing on the side with the variable, I see I've got multiplication there. I'm going to cancel that out with division. And little alarm bells are going off in my head because I'm dividing by a negative number. That means in the next line, I'm going to make sure I flip my sign. So over here, what's remaining is m. And then -12 divided by -4 is 3. Right, 2 negatives make a positive for multiplication and division. So what this final solution here is saying is that for the inequality -4 times m plus 2 is less than -10, for that to be true, m needs to be a number that's greater than 3. Got an itchy nose here. And again, I challenge you to choose a number greater than 3, plug it back into the original inequality, and see if you come up with a true statement. All right. So the last main skill we're going to practice today is graphing our one variable inequalities. So those solutions that we just came up with on this page here, we wrote them out algebraically, right, with letters, numbers, symbols. We could also represent them visually on a number line. And there's just a little system for doing that we're going to go through right now. So let's take a look at the first example here. It says 2 is less than x. So whenever you're using either less than or greater than, what you're going to do is you're going to put an open circle around that number on the number line. If you're using less than or equal to or greater than or equal to, you're going to put a filled in circle on that number on the number line. So we're filling it in because we're saying that we're including that number, right? It could be equal to that number. With these two symbols over here, we are not including that number, right? We kind of go up to it, but we don't include it. That's why we have an open circle that doesn't cover that number. All right, so first example here, 2 is less than x. It's less than, so I'm going to put an open circle here. And now the way I represent all of the numbers that x could be is with an arrow pointing in the direction that all of the numbers that x could be. So if I think about what this is saying 2 has to be less than x, right? 2 is less than x. So that means x could be anything that's more than 2, because 2 has to be less than it. So that means my arrow should point in this direction. I want to show that I'm including all of the numbers that are more than 2, because 2 has to be less than x. Right, I could take this inequality and I could flip it around. X is greater than 2. It would have the same meaning. So this is 2 different ways of saying the same thing. Actually, 3 different ways if you include the number line. All right, let's look at the example underneath here. It says x is greater than -3. So we're talking about the number -3. It's a greater than sign, so it's an open circle. And x is greater than 3. So x is any number that's more than 3. That means I should be pointing to all of the numbers that are more than -3. Just put these in their own little box here. Okay, on to the next example. We have x is less than or equal to -1. Well, I've got a less than or equal sign there, so I'm going to put a closed circle, a filled in dot. Oops, nope, it's -1, it's not 1. On the wrong side of the 0 there. Okay, try that again. So close in circle over -1. And we're saying x is any number that's less than or equal to -1. So we're going to point to all of the numbers that are less than -1. All right, and then our last example here says 0 is greater than or equal to x. So I'm going to put a closed circle at 0, filled in dot. And now 0 is greater than or equal to x, right? 0 has to be greater than x. That means x is less than 0, right? We can flip this around. We could think of it as x is less than or equal to 0. And so we want to point to all of those numbers that are less than 0. So our arrow points to the left. Okay, let's get a little more practice here. Now, it says solve, then graph the solutions to the inequalities below using a number line. So these are 2 examples that we actually just solved together. So what I'm going to do is I'm going to challenge you to pause the video and solve these inequalities again. See if you can reproduce what we just did together. And when you're ready, come back. Okay, so this one here, I'm just gonna go through the steps here. You can watch me, and I'm not gonna talk through it. See if you can narrate what's happening to yourself. All right, there's my solution. X is less than 7. So I want to graph this on a number line. I'm going to make a number line. We're going to keep it really simple here. I'm just going to put the number 7. I don't need to put the other numbers because number lines are always set up in the same way, where as you travel to the right, you're increasing. As you travel to the left, you're decreasing. So I know, and anybody who looks at this should know, that on to the right of 7 here would be 8, right? And then 9, 10, 11. To the left would be 6, 5, 4, 3, 2, 1, 0, -1, and so on. So I'm just going to keep it real simple and put that 7 there. Now x is less than 7, so it's going to be, I'll change colors here. It's going to be an open circle, and we're talking about numbers less than 7, so we point in that direction. All right, let's take a look at this one. Now again, I'm just going to work through this solution without narrating it. See if you can do that yourself, and then see if you can narrate this as you watch me do it. Okay, so now let's graph this solution. It says m is less than or equal to 3. Again, I'm just going to put 3 there on my number line, and I know what numbers come before and what numbers come after 3. It's less than or equal to, so we get a filled in circle. And m is less than or equal to, so we're going to point to all of the numbers less than 3. And that's it. Okay. So we're going to finish up our lesson today with 3 word problems. So giving us a chance to apply these skills of writing, solving, and graphing inequalities to word problems. Number 1, to ride the tornado blast roller coaster, you must be at least 54 inches tall. Choose the inequality that represents this situation. So again, this is a chance to focus on our key words here, at least 54 inches. At least means that we can be more than 54 inches or we can be 54 inches, right? So that's going to be greater than or equal to 54 inches. Our height needs to be greater than or equal to 54 inches tall. So choice D is our final answer. All right, so now we're gonna basically take that same situation and we're gonna graph it. So to ride the tornado blast roller coaster, you must be at least 54 inches tall. Graph the inequality, H is greater than or equal to 54 on the number line below. So I've already drawn the number line. It says H is greater than or equal to, so that's gonna be a filled in circle. And we are talking about numbers greater than 54. So my arrow will point to all of those numbers that are greater. And that's number 2 done. All right, now on to our final problem here. It says number 3, Ronaldo is purchasing face masks for his business. He may spend no more than $100. Masks are 50 cents each plus $20 shipping. First, write an inequality representing the number of masks and that Ronaldo can purchase. Then solve the inequality. Finally, graph the solution on a number line. Okay, so this is a multi-stage problem here. We have 3 tasks. The first task is to, it says first write an inequality. The second task is to solve the inequality. And the third task is to graph the solution on a number line. So we're going to take this one step at a time. Okay, so it says he may spend no more than $100. No more than $100. No more than. So that means whatever it is that he spends, so whatever he spends, it can go up to $100. It could be $100, but it can't go over. So we're talking about his spending being less than or equal to $100. So now we're going to take the rest of this information here and use it to fill in sort of the components of what he's paying. So masks are 50 cents each, and we know we're going to use N to represent the number of masks, and then we've got that plus $20 shipping. So we got kind of the mask fee and then the shipping fee that together make up the total. So masks plus shipping need to be less than or equal to $100. Okay, so we know the shipping is 20. Fill that in. Now what about the masks? What is he going to be charged for the masks? Well, it depends on how many he buys, right? So it's going to be 50 cents times whatever number of masks N that he purchases. I'm going to shorten 50 cents to just 0.5, right? Half a dollar. So 0.5 N plus 20 is less than or equal to 100. 50 cents times the number of masks he buys plus the $20 shipping fee needs to be less than or equal to $100. Now, if you wrote an inequality for this on your own, yours may have looked a little different. So again, with addition, the order doesn't matter. So you could have had 20 plus 50 cents times N. You could have flipped that around. You could have written it with dollar signs in there. I just didn't include the dollar signs, but you could have included them. You could have also flipped around the whole inequality. So you could have had 100 is going to be greater than or equal to all of this stuff. I think that way is a little bit harder to think about because we read from, right, we read from right to left. We read these symbols from, sorry, from left to right. we read from left to right. We read these symbols from left to right. So I just think it's a little bit easier to kind of read the sentence aloud to yourselves if you write it in the order that we started with here. But there's lots of different ways to write it. And if you are unsure about whether or not the way you wrote it is correct, ask me. Send me your answer and ask me to double check it. I'm happy to do that. Okay, so we have written our inequality. We're going to move on to our next task, which is to solve the inequality. I'm going to switch colors here. Let's go with blue. So we're just going to follow the same steps that we practiced before. I'm going to take care of that addition first by subtracting. Those 20s will cancel out. We're going to be left with 0.5N is less than or equal to 80. Right, so what we have now actually in the middle of solving this is we have a statement about what he can spend on the masks if you kind of exclude the shipping, right? So we canceled out the shipping from this statement, and now we're saying 50 cents times the number of masks he buys needs to be less than or equal to $80. So the 80 is kind of the portion that he's able to spend on actual masks, excluding that $20 shipping fee. And then to cancel out that multiplication, we're going to divide. Divide both sides by 0.5. And we get this solution of so we've got this solution of N is less than, got a mosquito in the house here, guys. N is less than, I'm going to pause the recording and take care of this mosquito. Hold on 1 second. All right, the mosquito disappeared. We don't know where it is, but maybe it'll turn up in a second. All right, so let's continue. Our solution is going to be the number of masks is less than or equal to, what is 80 divided by 0.5? Well, dividing by a half is like multiplying by 2. So 80 divided by 0.5 is 160. Right, if you have $80 to spend, each mask is going to cost 50 cents. That means you can get 160 masks for those $80. Okay, and that is our solution. We finished the second task for this problem. And now we're going to graph the solution on a number line. So I will change colors again to a nice purple. All right, get our number line set up here. We're talking about the number 160, so I'm going to put that in the middle. You can fill in the other numbers to the left and to the right of 160, or you can keep it simple like this. All right, it's a less than or equal to sign, so we know we're going to have a filled in. We're going to have a filled in dot here. And then the number of masks can go up to 160, right? Less than or equal to 160. Can't go over. So it's any number less than 160. So my arrow will point to the left. All right, and we are all finished. So here's your to-do list for this week. Now you've already done the first thing on this to-do list, which was to watch the recorded lesson. And then for the rest of the bullet points here, I've got a list of the different assignments and posts that are going up on our Google Classroom. So on Monday of this week, you have your problem of the day assignment. That's just one problem that is really similar to one of the problems that we did in the lesson here. I also always put up an introduction post on Mondays, just kind of going over the plans for the week. You've also got a vocabulary list and online learning links post. That vocab list and online learning links post, well, it contains the vocab list for this week, but it also contains links to YouTube videos by other people that go over the same information that we worked on in class, and they're shorter videos. So if you're wanting more examples, a little more explanation for writing inequalities or solving inequalities or graphing inequalities, definitely check out that post and watch some of those videos. On Tuesday of this week, the vocab quiz assignment goes up. This is really optional. It's something you can do if you'd like, but it's an opportunity for you to challenge yourself and test yourself on your vocab knowledge to see if you did a good job with studying our vocab list. And last week, I put up a post showing you how to use the vocab lists that I post. So how to study with them, how to use the website that they're on. So definitely check out that video if you feel like you need an overview of that. On Wednesday, you've got your Worksheet Wednesday assignment. That's a little bit longer, should take about an hour or so. On Thursday, we're going to have a study skills post go up. And then Friday, you have your final assignment, just one problem of the day to work on. All right, guys, I hope you're having a great week, and I will talk to all of you soon. Take care.